So what we have here, we've split out one of our plasticity indexes. We're going to perform this test on a -40 fraction. We kind of broke it down and got it partially prepared through a -4, and now we're going to go ahead and run it through a number 10 screen and a number 40 screen. Anything that falls through that 40 screen is going to be what we're utilizing for our plasticity index. 40 screen is very small. It's 0.0165 inches, so 1.65% of 1 inch. It's a very fine fraction, a very fine grain. Place the material in there, shake it down. And the clay particle is very temperature sensitive. We have to dry these materials back at a low temperature, under 140 degrees. It will alter the clay particle if it's exposed to heat greater than that. And so that's what we've done here. And we'll break it down. We're going to break it down further in our pestle and mortar. And that's to aid in the separation of the fine particles from the coarser particles and get down to that -40 fraction. For the plasticity index, there's two tests to it actually. There's a liquid limit and a plastic limit. The plastic limit test is we're going to dry the sample back by rolling it, and we're going to dry it back to a point to where the soil loses its plasticity and is no longer able to bond to itself. And at that point, it's its plastic limit. It is no longer plastic enough to bond to itself, and it crumbles. And at that point is the plastic limit of the soil. And we'll determine what the plastic limit is at that point by sampling it when it breaks up, putting it in the oven, and determining the moisture content on it. So we're going to roll it on this frosted glass. This is like the real nitty-gritty stuff of these tests. And right here, we're approaching our plastic limit on this one. And at this point, the soil is no longer able to adhere to itself, and we're going to go ahead and take a sample on that. We're going to keep rolling this material until we have enough of a sample as determined by the method to get our moisture content, and we're going to fill 2 of these with material from the plastic limit and determine that % moisture content. That's not wanting to roll for me. The purpose of the frost plate, it has a surface area with the frost on it, and that frost removes the moisture from this sample. Here we are again. Have gotten this material to where it's no longer able to bond to itself or have any more plasticity, and we'll continue sampling that. This is the drier point of this test. The wetter point of this test is going to be our liquid limit, so we're finding the bottom end of the moisture of its ability to adhere to itself. And then we'll find out also in our liquid limit the point at which it's gone from a solid state, by definition of this method, into a liquid state. We've rolled out a sufficient amount of sample for this plasticity, so we're going to go ahead and record our weights. We're going to place these in the oven to dry back, and we'll get the moisture content. That'll tell us what's the plasticity, the plastic limit of this material is. The other portion of this test is going to be our liquid limit. We have our sample prepped right here ready to go. We also have our our liquid limit apparatus right here. We're going to subject this material to X number of blows, and where it meets together in the middle at 25 blows is considered its liquid limit. Depending on how much clay is in this material, it's going to bond more to this brass cup. The more plastic it has, the less it's going to want to flow together. The more water I'm going to have to add to the material to get it to flow. And once it flows together at 25, that's considered its liquid limit. We take 3 different samples at 3 different moisture contents. We'll plot that out and determine at 25 blows what % of moisture is in that sample. So we've got this mixed up. It's very important that we have proper mixes on these to make sure that we have a consistent moisture in this material. This test, for the most part, is going to be a big factor in your geotechnical reports, and it's going to be a specification on almost any project that you're a part of. We're going to place the material in this cup. And we're going to run a groove down the center. And we're going to do drops until it flows together at the center. All right, we're at 33 blows on this one. It's met in the center, and this is where we're going to obtain our sample for a moisture content. We'll record that weight. And that's going to be we'll record the blows that it took to get that to close, and then we're going to record the weight and we'll get a moisture on that one. We're going to add more water to it to make it flow together. Again, that was at 33 blows, and we're going to wet it up so that it closes in less blows, and we're going to end up straddling that 25 blow count at some point. And we'll be able to graph that out and find out what its moisture content is at 25. We'll return this material back to the cup and add more moisture. It's important to me that I have my cup 100% clean, 100% dry in between each one of these tests. Cleanliness and dryness and keeping things consistent are very key to this test. This is a very picky test. We don't just let anyone perform this test. It's something that I want to have an amount of confidence in the individual that's performing this one, because sometimes on the plasticity requirements or the PI requirements on a specification, the threshold's pretty low, and so you want to make sure that you do have accurate results for it. We'll add a little bit of moisture, blend that up, get it closer to being a liquid. All right, we've got that moisture thoroughly mixed. We're going to go for our second set of blows. And since we've added water, it's going to close faster this time. There's a number of different methods for this test. There's an AASHTO and ASTM. Some DOTs have their own methods. We're right here running a 4318 ASTM, so we're using this particular groove tool. Your AASHTO groove tool is going to look a little bit more like this. This will close faster and give you a lower PI value. So knowing your specification laboratory, knowing which method is to be ran, it's going to make a difference whether you run it AASHTO or whether you run it in ASTM. Go ahead and cut this groove. Again, we're counting to see where it closes, and it has to have closure of 10 millimeters. Right there we have our closure at 18. We went from a 33 to an 18. That's a little bit more than I wanted. At this point I'd probably dry it back a little bit, get something in the middle. 18 I would want to be my third point. But we'll go ahead and get a sample on that and we can dry it back a little bit. Go ahead and record that weight. We'll set that aside. That's going to go in our oven. All right, now we've got our liquid limits completed. We got our 3 points on the liquid limit. We've also got our 2 plastic limits. We're going to go ahead and put these in the oven at about 230 degrees, and we'll dry them back, and we'll get weights on them. Once they've dried back, we'll be able to determine the percent moisture content on the liquid limit and the plastic limit. To find the plasticity index, we're going to determine that moisture content of the liquid limit and the plastic limit, and we're going to find the difference, and that is your plasticity index. If I have a 30% moisture at my liquid limit, and then I have a 10% moisture at my plastic limit, then we've got a 20 will be your plasticity index on that material.